Hello friends, I am Shilpa Bhagwat. Today we are going to learn very interesting topic from Science and Technology Part 1. In 9th standard, you must have learnt about Newton's laws of motion, momentum of body, theory of gravity and many such concepts. So today we will go in detail about the topic gravitation. Can you see that interesting GIF image on the screen? A person is sitting under a tree. Suddenly, a fruit falls on him. Now, this reminds me of a very famous scientist, Sir Isaac Newton, because of whom we know the concept of gravitation. Because of Sir Isaac Newton, we know very well the concept of gravitation. So, how can we define gravitation? Gravitation is the force of attraction between two bodies. All the objects in the universe attracts each other with a certain amount of force. See, here is our solar system. Aren't you curious that all these planets move in a particular orbit? Particular orbit only. Why does it occur? And the answer is simple, gravitation. Yes, answer is very simple, gravitation. There is force of attraction between sun and the planet, due to which these planets move in their respective orbits only. Now, let's see a short video to know concept better.
If there are two objects A and B with masses m1 and m2 separated by a distance d, then the gravitational force between them is given by this formula. And uppercase G here is called the universal gravitational constant, and its value is approximately equal to 6.673 times 10 raised to negative 11 Newton meter squared per kilogram squared. The gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This is the universal law of gravitation.
In this small clip, we have learnt about Newton's universal law of gravitation. The law is F is equal to G into m1 into m2 divided by d square. In this equation, F is the force, J is the gravitational constant, m1 and m2 are the masses of the two distinct bodies, and d is the distance between them. Now, let's see this clip. Imagine that you are having a tennis ball attached to a string and you start swinging it in a circle. You are swinging that ball in a circle. You must have heard about Newton's second law of motion, that is F is equal to ma, which is related to the object moving in a straight line. It also tells about the force on an object as it moves in a circle. As the object is moving in a circle, that means the velocity is changing. Velocity is changing its direction, which means that there is an acceleration. And from Newton's second law, we have acceleration, we also have net force. And this net force for an object moving in circle towards the center, which is also called centripetal force, that is center seeking force. if we cut the string, then that ball goes in a tangential path. That is tangential velocity. In this clip, we can see tangential velocity as well as centripetal force. Now we move towards Kepler's laws of motion. Kepler's first law of motion is the orbit of a planet is an ellipse with the sun at one of the foci. Let's see one short clip regarding this first law.
Let's now try to understand Kepler's laws. He did a lot of good work. Now, according to Kepler's first law, all the planets revolve around the sun in their respective elliptical orbits, and the sun is one of the foci.
Let's move towards Kepler's second law of motion. The line joining the planet and the sun sweeps equal areas in equal interval of time. The line joining the planet and the sun sweeps equal areas in equal intervals of time is the second law. Now let's see the clip regarding this law.
Look at the figure carefully. The line joining the planet and the sun sweeps out equal areas in equal intervals of time. So you see that these two areas are equal.
Kepler's third law of motion. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of planet from the sun. If the period of revolution is t and the distance between the planet and the sun is r, then the law is t square divided by r cube is equal to k. In this case, k is the constant. So, today we learned some very important concepts of physics, that is gravitation, Newton's universal law of gravitation, the centripetal force, Kepler's laws of planetary motion. Now, where can we apply this knowledge in our day-to-day lives? Think about it, and thank you for watching.